BOE students, here to discuss the VEX robotics platform. What you guys are going to actually be using to program, to learn generally how to program, learn different sensors, and how these different sensors and motors and servos can come together to create a controlled device, which is going to be at the end for your major project. So let's first start with this. Some of our VEX equipment. When we look at the test bed right here, we have a railing that goes across, and we have three things that look like, black boxes. These are essentially devices to create movement. Two of them, the outsides, are motors, and the inside is a servo. So real quick, servos, I'll start talking about these first. Servos are incredibly awesome. They can go to almost any position that we want them to, between 0 and 120 degrees. So I'm just going to go ahead and kind of show you an example of how to edit these, how to manipulate these a little bit. And I'll talk more about this. So you see I had a little issue there. Let's go. All right, we got motors up. Okay, so we got something called a servo right here, and there's a power value. For servos, power values actually just identify where it is. So in this case, if I wanted to, I could type in 127. You could see that my servo moved here. If I go to negative 127, it'll move all the way around. So the power values are negative 127 to 127 for almost anything. But you got to be careful here because this number does not denote the position that it's in. Negative 127 is actually 0 degrees for the servo, and if I change it to 127, it'll move all the way to 120 degrees. So you can actually do a little bit of math and divide there to figure out, okay, if I needed to go to 55 degrees, what power value is that? For example, right in the middle of 0 and 120 degrees is 60 degrees. That's right in the middle of the power value scale, which is 0. So I could put a power value 0, and my servo will be at 60 degrees, right in the middle. So those are servos. They cannot make a full rotation around. Don't try it. There are mechanical limiters inside of the casing that prevents that to happen. Also be very careful how you use these. Any noise that's coming from them, we don't like that. These servos can burn out very, very easily, so be careful when you are manipulating them. On the outside, let's talk about motors. The two motors here, this one and this one, they are what's called 269 motors. And a motor can actually make a full rotation around. So these motors do have axles attached to them. I did put wheels on them, so those can make full rotation. So for example, I have my right motor here. I can change that power value to 127 or 63. We'll go 63. And you can see that over here it is spinning at a value of 63, which is about generally half of its power one way. I could go negative 63 and it will rotate the other way, and 0 to turn it off. Motors start with just 2 wires, ladies and gentlemen, so I'm going to try to show you here a little bit. The motor coming off only has 2 wires, and coming up they are red and black. For this to be able to work inside of the VEX microcontroller, it needs something called a motor controller. This motor controller has a little gray box on it. It even says motor controller 29. It has to be connected to a motor for you to be able to manipulate it. For you to be able to program it and have it run left and right, you have to have one of these. If you don't and you just stick this inside, either it's always going to rotate one way, it's never going to do what you want. So, ladies and gentlemen, you might see this on the quiz. Always need a motor controller with a motor when you want to control it. That's incredibly important. So I'm going to plug those back in right there. Again, always need a motor controller with a motor. These can turn all the way. They can do 360 degrees multiple times. So awesome little components to create some kind of movement or rotation. Some of our VEX sensors. So we do have some sensors. I'm going to go to my sensors tab. And these sensors are what you're going to use to maybe even control those motors or to be able to control different portions of your device. So for example, one of the first ones we have is essentially just a bump switch right here. It pushes up, pushes down. You can see if you look on this line where it says digital 2, that's the portion that it's in. Its name is bump switch, and it's a touch sensor. And you can see when I press it and hold it down, it's a 1, it's 0, 1, 0. This is a digital sensor, ladies and gentlemen. That means that it's not analog. It doesn't have a range of values. Okay, look at that, 0, 1. Doesn't have a large range. It's either off or on, either 0 volts or 5 volts from the battery. So that's very important to take note of. The next one is another digital sensor. Let me move out of the way. This is our limit switch, which is right here. It's essentially just a red box with a little metal piece that's attached to a spring. When I press and hold that down, that is 1. When it's off, it's a 0. Again, another digital sensor, either on or off, 1 or 0. Moving on, what these could be useful for, I guess I should explain. You can actually use limit switches to, engage or close something. So for example, you have a gate. A motor could be running here, and this gate could go up and down. I know it's hard to see with my hand, but the motor could close it or open it, and the motor will run until, boom, it hits that limit switch, and the gate's closed. So you can think of, okay, how do these gates work? When I go to a parking garage and I have to pay, the gate opens, I go through. That's one way. You pay, it says open until it hits limit switch, car drives through, close until it hits limit switch. Could be something very, very similar to that. Bump switches, also for the same thing, they're just a little bit more rugged. So if you need an application that could be really hitting or pounding on this switch, something that could be very strong, you might want to use a bump switch. They're very, very strong. Shaft encoders. So we do have something called a quadrature encoder. It's this device right here. It's very, very large. It can be bulky and kind of a pain in the butt to use. But if we turn this device, our quadrature encoder will actually change. So you can see here that our quad right now is 5,000. I can turn this all the way back down to 0 if I wanted to. The misnomer a lot of people think is this is an analog device. A quad encoder is actually a digital device. It's a counting device. So 1, 2, 3, 4. It doesn't have the greatest resolution. You can see here I can't go to 6.5 or 6.66, whatever it may be. It just counts one at a time, and the program, as it moves, the program is actually adding all of our values together to see how many that we have. So I could break down what's inside a quadrature encoder. Essentially, it's a metal plate with a bunch of holes in it, passes over a sensor, and then every time that happens, it counts. So our quadrature encoders, they're very, very strong. They're very useful because you can control, say, how many rotations you want a motor to run. So for example, if I wanted to, right now I have a program that will start a motor until the encoder counts 350, and then it'll stop a motor. So you can kind of see how that works. We can see if it'll actually work here. So I'm going to go ahead and just start this motor, start the program. Right now my quad encoder is 0. As I turn my quad encoder and I hit 350, it should stop. So I did actually just hit 350, it didn't stop. It's supposed to start it. Once it hits 350, it's supposed to stop the motor. It actually is doing that. It's my problem. I actually have a while loop right here. If I get rid of this while loop, then it should work. It was stopping the motor, but the while loop was just continuing the program so quickly that you couldn't even tell. So let's try this again. So go 350, there you go. I stopped at 388, but it did stop it. So you can actually control the position or how far something moves. Next one, light sensor. So we do have a light sensor. This is an analog. This is analog, ladies and gentlemen. As I decrease the amount of light, you can almost think of it as like a variable resistor. As I decrease the amount of light, the resistance of this light sensor actually goes up, and that's an analog. It has a nice range of values. You can see that it fluidly changes different values. The next one we have is a potentiometer. Please note this, ladies and gentlemen. This is the potentiometer right here. Very similar to a quad encoder. As I turn this, you can see that my potentiometer value is actually decreasing. So it can go all the way from 0 to, all the way over, 4,095. The potentiometer, ladies and gentlemen, does not make a full revolution. It cannot make a full revolution. So if you are putting this on a motor and a motor needs to make a full revolution for whatever it's doing, get it off there. If you make this potentiometer go a full revolution around, you'll break the mechanical limits inside, and then it's pretty much useless and it doesn't help us with anything. It won't sense properly anymore. It'll have what's called a dead zone, which we don't want to deal with. So again, a potentiometer cannot make a full revolution around. Don't try it, you'll break the limiter. But it's, again, it does rotate quite a bit. It's about 270 degrees, I believe, and it can count all the way up to 4095. So it can count 4,000, over 4,000 degrees, or say it could count 4,000 in only 270 degrees. So it's incredibly accurate. You know, just turning it a little bit can give me a huge range of value. So if you need something to be very, very accurate in its position, you can use a potentiometer for that. After that, we have a line follower, which is this this guy over here. Generally, it kind of senses the difference between light and dark surfaces. So in this case, right now, it's sensing a high value, but as soon as I take my finger and I put it over there, my finger is a light surface, so it will give me a lighter value or a smaller value. Generally, we don't use them a lot, but they are used for a lot of motion, especially if you ever see robots in factories working, they might be following black lines on the ground. That's actually line followers underneath that robot following that black line. So if it ever hits the surface that the black line's on, that might be white, like a white floor, then it says, oh, I got to get back on track, and it's got to find that black line again. Next, Robotc. So I've only got a few minutes left. What is Robotc? So you can see this is Robotc. It's called an IDE, or an interactive developer environment. Essentially, this is where we write code. There's text functions on the left that we can drag and drop, and we also have something down here called a debugger window, and we can manipulate values inside of the debugger window, and we can see what our sensors are doing. So we've been using this a lot. As I change a sensor like the quad encoder right here, it will count up and down. So you can make sure, you can use the debugger window to make sure something's working or working correctly. So like I said, I can go to the debugger window and I can tell, you know, my left motor to turn on a full power one way, or 63 power, half power one way, and it will turn. Debugger window, very, very useful for troubleshooting any kind of code, or troubleshooting how you hooked up motors or sensors. And lastly, I just wanted to talk just slightly about pseudocode. So if I go over here, what is pseudocode? Essentially, you speak English, say this is what I want to happen. You write that stuff down. Generally, you start with 2 backslashes and you write it down. For example, for this program, I want to start a right motor if the limit switch is pressed. It's in green. I use 2 slashes to be able to do that, and then I can break down the code exactly what I need. So pseudocode's very, very good for getting down what we want our program to do in just, you know, terms like reading English or talking English. There we go, conversational English. And then we can take this complex behavior and break it down into simple steps that will satisfy that complex behavior. So again, pseudocode, very, very powerful. I'm going to be expecting that you guys actually write pseudocode for all of your actual code that is completing whatever program you're writing. Again, all this done in Robotc. Robotc is an IDE, or interactive developer environment. There are many, many different ones out there, like Arduino has their own, Java has their own. Java actually has a few different ones. I shouldn't say Java, but there are different developers who created their own developing environments for Java, for C++. So there's quite a few of them out there that you can manipulate and use. So again, take a look at the PowerPoints 3.1.1 to 3.1.3. Take notes on those. Watch my video. You watch the video here, rewatch them. After you feel you have a good enough set of knowledge, then go ahead and attempt the mastery quiz. Thank you.